You double-click an icon, right, and a loading screen pops up.
Yeah, it's just muscle memory for most of us.
Exactly. But in the milliseconds before that game actually launches, there is this invisible war raging inside your system's memory.
A very expensive war, actually.
Right. And we aren't talking about like abstract sci-fi concepts here. There is a relentless, high-stakes arms race constantly churning between multi-million-dollar corporate security firms.
And, well, highly organized shadow syndicates of software engineers.
Yes. So every time you boot up a game, you are stepping onto a digital battlefield that has basically been evolving for 3 decades.
And the crazy thing is, most of us are completely oblivious to this whole ecosystem.
Oh, totally.
Like, you see a publisher's logo flash on the screen, but beneath that surface, there is an incredibly dense web of encryption, hardware checks, and counter-surveillance.
All actively fighting to maintain control of your machine.
Right. The scale of the engineering on both sides of this conflict is genuinely staggering.
Which is exactly why today we are unpacking all of that. We're doing a deep dive into this brilliant breakdown from the YouTube channel Softlings.
Yeah, the video is titled, How Hackers CRA Every Game in Minutes.
It's such a fascinating watch. The mission for today's deep dive is to trace the complete 30-year evolution of video game security. Right.
We're going to look at the underlying logic.
Yeah.
I mean, the actual computer science behind the methods hackers use to bypass these defenses.
And ultimately, we'll explore how this relentless cat and mouse game has, completely changed what it means for you to actually own digital media.
Because that definition of ownership is really the collateral damage in this war.
Yeah, that's a great way to put it.
Every new security measure implemented by developers is a direct response to a previous compromise.
And then, of course, every new exploit from a cracking group is a response to that latest security measure.
Exactly. It's an endless loop. So to understand where we are now with massive cloud architectures and dynamic encryption, we really have to look at the foundational flaw of early software security.
Right, let's start with the 90s. Because the logic back then was it was so innocent.
It really was.
Security was almost entirely physical. You bought the chunky cardboard box, and your security clearance was literally just the CD key printed on the back of the paper manual.
Usually in tiny font, yeah.
Yeah. And I always think of the early CD key like an incredibly lazy bouncer at a nightclub.
Oh, how's...
Well, you walk up, and this bouncer doesn't check a guest list. He doesn't ask to see your ID or anything. He just asks you to solve a logic puzzle.
Like a riddle.
Exactly. He's like, what's a number that's divisible by 7 and ends in a 3? You say 63, he unclicks the velvet rope and you're in.
That's actually a perfect analogy.
Yeah.
Because the game software wasn't verifying a transaction at all.
It was just checking the math.
Right. It was executing a simple mathematical validation.
Yeah.
It basically ran the string of characters you typed through an internal checksum algorithm just to see if the resulting output matched a required value.
But the fatal flaw there is that the developer handed both the lock and the criteria for the key, like directly to the user.
Exactly. All the validation logic lived locally
Mm-hmm.
on the user's machine.
So if I'm a hacker in 1998, I realize I don't need to guess the keys.
No, that would take way too long.
Right, and I certainly don't need to run the complex algorithm backward, which is, mathematically impossible for good cryptographic hashes anyway.
Right.
I just need to isolate the part of the code that checks the math.
Precisely. Once they see the internal logic the game uses to validate a key, they can just write a separate piece of software.
The famous keydins.
Yeah, a key generator. And it uses that exact same logic to spit out an infinite list of numbers that fit the criteria.
Meaning the developers effectively shipped the lockmaker's blueprints inside every single copy of the game.
Which was devastating. I mean, Keegan's decimated retail revenue because the workaround was completely frictionless for the end user.
You just click generate, copy, paste, and you're playing.
Right. So the industry quickly realized that relying on a static mathematical puzzle was a dead end.
Which led to the escalation in the early 2000s. They shifted the focus back to the physical medium itself.
Yeah, systems like SafeDisk and Securum.
Oh man, those names bring back some serious system crash memories for me.
You and millions of other people.
Seriously. But the idea there was to move away from typed codes and force the software to actually communicate with the hardware, right?
Exactly. The game would interrogate the CD-ROM drive and look for specific manufacturing defects on the actual disk.
Like microscopic bad sectors.
Right. Intentional scratches that a standard consumer CD burner just couldn't replicate.
So if it didn't physically feel those exact intentional scratches, The game just refused to launch.
It was a smart attempt to anchor digital software to a physical object. But the cracking groups recognized a brand new vulnerability.
Because they didn't need to spend millions of dollars buying industrial disk pressing machines to replicate physical defects.
No, not at all. They simply had to compromise the communication channel between the game executable and the operating system.
Because the game isn't actually touching the disk.
Right.
The game is just asking Windows to check the disk. And if you have admin access to your own operating system, you can just, well, gaslight the game.
That's a good way to phrase it. Hackers built virtual drive software that basically intercepted the game's hardware request.
Like a phantom drive.
Exactly. So when the game asked, hey, are the bad sectors there? The virtual drive intercepted the call and fed back the exact data signature of an authentic disk.
Wow. So the developers hit a wall again.
A massive wall.
Yeah.
Whether it was a mathematical algorithm or a hardware check, the fundamental vulnerability remained.
Because if the verification process happens entirely on a local machine...
That local environment can be manipulated to lie.
Right. So the only logical countermeasure for the industry was to revoke trust in the user's hardware entirely.
They had to seek an external authority.
And that takes us straight into the era of always online DRM, or digital rights management.
The dreaded always online era.
Yeah, so instead of the game asking the computer if it's legitimate, the game, dials out to the publisher servers to check a master list.
Which functions like a VIP guest list.
Yeah.
And Ubisoft took this to a notorious extreme in 2009 with Assassin's Creed 2.
Oh, I remember this vividly.
Ubisoft implemented a system they publicly touted as uncrackable.
Which is always a dangerous word to use.
Very. And the parameter was brutal. The software required a constant, uninterrupted connection to Ubisoft's servers.
It wasn't just an initial handshake at the main menu, right?
No, the game pinged the server continuously. So if your router dropped a single packet,
or your internet connection flickered for even a second,
the game instantly froze. It just locked you out until the connection was fully restored.
which is just an incredibly aggressive stance against paying customers.
Highly controversial at the time.
But, like we said, waving an uncrackable flag is basically issuing a formal invitation to the global cracking community.
Oh, absolutely.
Yeah.
It's a challenge.
And the SoftLinks video points out that within 24 hours, literally 24 hours, this massive multi-million-dollar infrastructure was completely bypassed.
The speed of it was staggering.
And the method here is brilliant because, again, the hackers didn't attack Ubisoft's servers directly. They applied that phantom drive logic, but to the internet connection.
Right. They executed what's known as a local man-in-the-middle attack.
It's like a rogue postman.
A rogue postman.
Yeah, so if the game is writing a letter to Ubisoft asking for permission to run, the hacker software acts as this rogue postman.
Okay, I follow.
He intercepts the letter before it ever leaves your computer, rips it up, and just hands you a forged reply that says, Ubisoft says you're good to go.
That is exactly what happens. The actual execution of that is fascinating, technically speaking.
How did they do it?
Well, the hackers modified the user's local host file, which is essentially the operating system's internal address book.
Okay.
So when Assassin's Creed 2 tried to connect to the specific web address for Ubisoft's DRM server, the host file rerouted that traffic internally.
Wait, so it never went to the internet?
Never. It pointed it to a miniature counterfeit server program running silently in the background of the user's own machine.
Oh, wow. So the game believed it was having this secure, encrypted conversation with a corporate data center in France.
But it was actually talking to an echo chamber sitting right next to it in the system memory.
That is just pure software or social engineering. They essentially isolated the executable in a simulated reality.
The Matrix, basically.
Yeah. So, okay, if I'm a developer and my local hardware checks are getting spoofed,
And your external server checks getting rerouted locally.
I mean, what do? I have to design a lock that fundamentally intertwines itself with the unique physical properties of the specific computer it's running on, right? So a generic fake server won't work.
Exactly. Which brings us to the Denuvo boss fight.
The ultimate boss fight.
Denuvo anti-tamper completely disrupted the cracking scene. It is not traditional DRM. It operates on an entirely different philosophy.
Because traditional DRM is just that gatekeeper checking a list.
Right. But Denuvo is a dynamic obfuscation engine. It actually encrypts the game's executable code while it is running.
It scans the specific hardware ecosystem of the machine it's installed on, right? Like the serial number of the CPU.
The motherboard architecture, the storage drives, all of it. and it generates a complex cryptographic token based on that exact hardware profile.
So the execution code of the game is woven directly into that hardware token.
Exactly. This is why Denuvo is so notoriously sensitive. If a user swaps out their RAM sticks or even installs a significant Windows kernel update, the hardware profile shifts.
So the cryptographic token no longer matches the physical reality of the machine.
Right. And the software just locks down, assuming it has been pirated.
Wow. And for a long time, the cracking groups went completely dark. Because you can't just build a universal rogue postman anymore.
No, every single installation requires a totally unique, hardware-specific key to decrypt the game in real time.
So to beat this, hackers had to stop looking at the static files and start looking at the live system memory itself.
They had to bring in professional reverse engineering software, specifically debuggers like IDEA Pro.
And IDEA Pro is like serious industrial grade software.
Oh, very much so. It's an interactive disassembler. It's a highly advanced tool used primarily by cybersecurity analysts to tear apart malicious software.
But in this context, crackers use it to monitor the CPU's sequential processing of the game's code.
Because Denuvo's encryption is constantly morphing, constantly unpacking code on the fly, it is literally impossible to analyze the raw files on the hard drive.
Right. The code only exposes itself in the fleeting millisecond it is loaded into the CPU's registers for execution.
Exactly, so they have to catch it in the act of unpacking.
Okay, so if the CPU is like a train track, right, and the instructions are the train cars rolling down the line.
IDE Pro allows the hacker to set a trap, a memory breakpoint right on the tracks.
Wow.
They tell the debugger to halt the entire system execution the exact microsecond the game attempts to validate that hardware token.
So the debugger pauses the CPU instructions. The execution is just frozen in memory.
Frozen in time. And then the reverse engineer can look at the raw assembly language, see exactly what cryptographic variables Denuvo is demanding, and analyze the validation logic.
That's insane. And then they perform like a surgical strike.
Yes, they write a custom patch that intercepts the game's request for the hardware token and forces the logic to return a true value, basically bypassing the trigger entirely.
They rewrite the train's cargo right before it reaches the station and then hit play again.
That's a great way to visualize it.
But the level of computer science required to comb through obfuscated assembly code and find one specific variable trigger among millions of lines of code, it's just staggering.
It's masterclass engineering.
Which completely shatters a major stereotype, honestly.
You mean the guy in a hoodie?
Yeah. The cultural image of a hacker is a lone teenager in a dark room typing furiously. But nobody's doing this alone.
No. The source material highlights groups like Reloaded, Core, and CPY. These are not loose collectives of hobbyists.
They are highly compartmentalized organizations.
Very much so. They actually mirror the structure of a Silicon Valley tech firm.
Because you have reverse engineers whose sole responsibility is to stare at IDA Pro and map out those obfuscated memory triggers.
Right. And then you have software developers who take those maps and write the actual payload, the crack itself.
And then importantly, you have dedicated testing divisions.
QA testers, essentially.
Yeah, checking the payload across thousands of different CPU and motherboard combinations to ensure the crack functions universally.
Because remember, the corporate developers building Denuvo are teams of highly compensated, brilliant engineers utilizing cutting-edge cryptographic theory.
So to counter that, the cracking syndicates had to adopt an identical corporate structure.
Exactly. The invisible war evolved into a clash between rival engineering firms, one legitimate and one operating completely in the shadows.
It's wild. But with the cracking syndicates getting that sophisticated, game developers realized they were caught in an unwinnable arms race on local hardware.
They were losing ground, so they started getting creative with their countermeasures.
Yeah, instead of just trying to block the software from running, some developers leaned into, well, psychological warfare.
Yes. Fade protection.
Yeah. Fade protection completely abandons the idea of a hard lockout.
Right. If the software detects it has been tampered with or is missing the correct security token, it actually allows the game to launch.
But it silently alters the internal variables of the game world to degrade the user experience over time.
The classic example SoftLinks brings up is Grand Theft Auto 4.
Oh, this is my favorite one. Rockstar Games programmed a trigger so that if a cracked executable was detected, the main character's in-game camera became permanently drunk.
Yes, it would constantly sway, tilt, and wobble.
And the cars would automatically accelerate out of control. The game was technically running, but it was nauseating and utterly unplayable.
It's a brilliant tactic because it accomplishes two things. First, it actively wastes the pirate's time, creating immense frustration.
Right.
Second, and arguably more importantly, it damages the reputation of the cracking group.
Oh, because users download the cracked version, experience the bugs, and assume the cracking syndicate just released broken software.
Exactly. It undermines trust in those illicit distribution networks.
It's hilarious, but it's still just a band-aid.
Ultimately, yeah.
The reality is, as long as the game's executable code is physically handed over to the user's machine, a dedicated reverse engineer using memory breakpoints will eventually find a way to strip the security out.
It's an inevitability,
Mhm.
and the industry recognized this,
Mm.
which led to the ultimate countermove.
Right. If the battlefield is a user's hard drive.
The only way to win the war is to take the battlefield away completely.
Enter server-side cloud gaming.
The shift toward cloud gaming fundamentally alters the architecture of digital media.
Because with services rendering games remotely, the heavy computational lifting like the physics engines, the graphical rendering, the execution of the core code.
None of that happens on the local machine anymore. It is all processed in a secure, centralized data center hundreds or thousands of miles away.
So your local hardware is essentially reduced to a dumb terminal.
Just an interactive video player.
You press a button on your controller, that input is sent over the internet to the data center, the server updates the game state, and streams a video feed of the result right back to your screen.
And the security implications of this architecture are absolute.
Because you can't crack what you can't touch.
Exactly. You cannot attach a debugger, like IDA Pro, to a process that isn't running on your CPU.
Right.
You cannot set a memory breakpoint on a server you don't have administrative access to.
Yeah.
And you cannot reverse engineer an executable file that never touches your hard drive.
So the era of local cracking is basically neutralized by the cloud.
Yes. To crack a cloud-based game, a syndicate wouldn't be reverse engineering consumer software anymore.
They'd have to initiate a literal cyber attack against a corporate data center.
Right. Extract the proprietary back-end server code, and then somehow provision their own massive, wildly expensive server farm to host the stolen game for users to stream.
Which escalates the activity from, copyright circumvention to high-level corporate espionage and infrastructure theft.
The logistical and financial barriers to doing that for free distribution are astronomical.
So the Softlinks analysis basically suggests this architectural shift could represent the genuine final end of the video game cracking era.
The industry might finally have its uncrackable system.
But pulling the software entirely into the cloud sparks a massive fundamental debate about consumer rights.
It certainly does.
And the source material touches on the specific ideology driving these cracking groups. Their motto is basically, if buying isn't owning, then maybe piracy isn't stealing.
It is a profound philosophical conflict that underpins this entire technological arms race.
Right.
Look at the developer's perspective. Publishers invest hundreds of millions of dollars and years of human labor into creating digital assets.
Huge investments.
They argue they have an absolute right to control the distribution of their intellectual property and ensure they are compensated for their work.
And from their vantage point, unauthorized duplication is an existential threat to the economic viability of the medium.
Exactly. But the users, and specifically the cracking groups, view the industry's security tactics as a slow, deliberate erosion of ownership.
Because 30 years ago, you bought a cartridge. You owned the physical object containing the code. It functioned completely independently of the publisher.
Right, you could put it in a box for 50 years, take it out, and it would still work.
But today, you pay $70 for a digital license, which is really just a temporary permission slip to access data on a corporate server.
And if that corporation goes bankrupt, or if the publisher simply decides it is no longer profitable to maintain those authentication servers,
That game, which consumers paid full retail price for, is rendered completely inaccessible.
it vanishes.
So the cracking syndicates argue their work is like a form of aggressive digital preservation.
By breaking the DRM and severing the software's reliance on external servers, they are ensuring the cultural artifact survives long after the publisher abandons it.
They see themselves not as thieves, but as archivists breaking the locks on a burning library.
And the push toward cloud gaming forces this conflict to a head. It completely eliminates the possibility of preservation by removing the artifact entirely.
The debate really challenges us to consider what a consumer is actually purchasing when they hit buy on a digital storefront.
Exactly. What are you actually getting?
I want you, listening to this, to really think about that dynamic. This has been an incredible 30-year technological journey we've mapped out today.
It really has.
We started with simple math checksums printed on paper manuals. Then we moved to faking the physical hardware signals of CD-ROM drives.
We saw the rise of always online DRM, countered by hackers manipulating network host files to build deceptive echo chambers.
We watched the industry deploy Denuvo's dynamic real-time cryptographic hardware tokens only for corporate-structured cracking syndicates to utilize professional debuggers to intercept memory executions mid-stride.
Just a constant back and forth escalation.
And now, all of that brilliant, exhaustive engineering has culminated in the cloud, locking the underlying code in distant data centers completely out of our reach.
The ultimate uncrackable vault.
Exactly. So the next time you launch a game or stream a movie or open a piece of cloud-based software, recognize the invisible architecture running in the background. You are experiencing the latest compromise in a 3-decade war over digital control.
A war that is constantly reshaping how we interact with media.
But as we wrap up this deep dive, I want to leave you with one final thought to mull over. We've seen that the ultimate solution to ending software piracy is to physically remove the product from the consumer's local machine, revoking our access to the underlying code.
Right.
So if taking the artifact completely out of our hands is the only way for corporations to achieve perfect security, what other aspects of our digital lives are we willingly surrendering total control over just to feel a little more secure?